All right, welcome to our next video in the series. This is going to be our video on recursion. Recursion is typically one of the most missed content areas on the AP test, and it is challenging, it's confusing, but it's a really fun and interesting idea. The idea is simply that a recursive method is a method that calls itself. So a very basic example of a recursive method would be that. So my method recur is now a recursive method. You might be thinking to yourself, well, that looks pretty useless, and also doesn't it cause a problem? And the answer, it does. If I go ahead and try to run this, Java correctly identifies that when I called recursion, it calls recursion, which calls recursion, and so on and so forth. The problem is I never get to escape this recursive loop. So how can we make a recursive method that's going to be useful? I'm going to give three examples. We'll talk about the definition of recursion and what's the syntax. We're going to define what a base and recursive case is. What are those cases? And then how can I show recursion with multiplication, exponents, and factorial? I want to start by saying that most of the examples that I'm going to give are not going to be best done with recursion. I think they do a good job of explaining what recursion is, but they don't do a great job of explaining. They wouldn't be the best way to tackle it. Factorial is a great example. Recursion makes a lot of sense with factorial. However, it is best done iteratively, which is the non-recursive approach. So let's actually go ahead and start with factorial. What is factorial? So I'm going to call this fact. Fact. We'll call it fact. And the idea is we're going to take an int n, int number n. And our idea is if I say fact of n, that means I'm looking for n factorial. Or perhaps a more specific example would be that fact of, say, fact of 4 is equivalent to 4 times 3 times 2 times 1. Okay, so that's going to be what factorial is. So it needs to have the name fact and a parameter, and we actually are going to try and return something. We're going to try to return an int. And I'm just going to put a little stub return right here for now. All right, so what do we do to make sure that our recursive method doesn't just run infinitely forever? That's going to be the first thing we got to figure out. And the next thing is, how do we handle different numbers? You know, obviously I can't just make a bunch of if statements. If n is 2, return this number. If it's 3, return that number. If it's 4, return that number. That doesn't make any sense. So how do I break this down? Well, you're going to break down every recursive method into a base case and a recursive case. That's what we do, a base case and a recursive case. So what does that mean? Well, the base case is your simplest situation, right? And the recursive case is really everything else. So what would be the simplest case for me? Well, how about if n is 1? If n is 1, well, factorial 1 is just 1. There's no fancy math needed to do with that. It's not complicated. I can just say it's 1. But let's say it's not 1. Let's say it's a number bigger than 1. Well, now we're looking at our recursive case. And the way to think about it, I'm going to go ahead and tuck these comments in here where they make sense. The way to think about it is this. When I am doing recursion, if I want 4 factorial, that looks an awful lot like 4 times 3 factorial. Well, that's going to look an awful lot like 4 times 3 times 2 factorial, which is going to look the same as 4 times 3 times 2 times 1 factorial. And then we just see that that's 4 times 3 times 2 times 1. And that gives us the correct answer, which I want to say is 24. Is that right? 12? Yeah, 24. So because every time we approach a new number, it looks an awful lot like a problem that is similar, meaning that 4 factorial looks very similar to the 3 factorial problem, which looks similar to the 2 factorial problem. It seems that what we could do is we could just say, you know what? Let's go ahead and return the number that we have now and multiply with it the factorial equivalent of the number that's 1 less than me. So what does that look like? I'm going to say, okay, return myself times factorial of n minus 1. And let me get rid of my little stub return right here. Okay. So this is, I'll bet this part probably made a lot of sense. This is the part that blows everybody up. What are we doing here? If I get factorial of 4, well, 4 is not 1, so I don't hit the base case. I go down to the recursive case. And now we say, okay, take 4 and multiply yourself by factorial of 4 minus 1, which is going to be 3. So we're going to say, how do you find factorial of 4? Well, it's 4 times factorial 3. And then we call this again. And we say, all right, factorial 3. How do you find yourself? Well, you're not 1. Well, you're going to be 3 times factorial 2. And 2 is not 1, so that's going to be 2 times factorial 1. And then 1 is going to be 1. It's just going to return 1, and the whole thing's going to resolve. So another way to think about this would be not just in terms of the math, but let's look at how Java evaluates the method calls. Because what's going to happen is factorial is going to get called a bunch of times. So originally, if I call, let's say up here, I'm going to store the answer in fact4. This should be, if I did this right, let's just go ahead and verify that my logic is good before we get too much deeper into the video. Run it. 24. Huzzah. Okay. So when I called fact4, what happened? Well, it said, hey, all right, fact4, the value that you are going to return is going to be the same as 4 times fact3. And that's going to be the same as 4 times 3 times fact2. And that's going to be the same as 4 times 3 times 3 times 2 times fact of 1. And then we know that we finally are hitting the base case. That's going to be the same as 4 times 3 times 2 times 1. And so there are 4 method calls that happen. Factorial of 4 calls factorial of 3, calls factorial of 2, calls factorial of 1. Now, all of these calls are sitting on top of the call stack, and they get resolved in reverse order of when they get called. What that means is factorial 4 is going to get resolved last. It was called first, but it doesn't know how to answer itself until factorial 3 gets resolved. And it doesn't know how to resolve itself until 2. 2 doesn't know what to do until 1. 1 goes and says, well, look, I'm just 1. And so then it returns itself times 2, and that's what factorial 2 becomes, which then returns to factorial 3, which then returns to factorial 4. This is one of the reasons that we use the term stack, because it's like stacking a bunch of plates, right? Factorial 4 is the first plate, 3 goes on top of it, then 2, then 1's at the very top. 1 resolves, so we can take that plate away, then factorial 2 resolves, we take that plate away, then 3, then on down to 4. So that's how factorial works. The thing you need to know with a recursive case is it must progress you toward the base case. I think there's probably some smart students watching this video right now that would recognize if I tried to do factorial with a negative number, this would fail. If I said factorial of -4, well, unfortunately, what would happen is I would continue to get an increasingly more and more negative number, right? How do you get factorial -4? It would be, you got to figure out factorial -5, which needs factorial -6, -7. So a weakness of my current factorial recursive method is that it cannot handle negative numbers, which don't worry about that. There's also something that we can talk about, you know, for the sticklers out there who know that 0 factorial is 1. 0 factorial is 1. Well, how do I handle that? Well, I could just add an additional base case if I wanted. If n is 0, if n is 0, then we could return 1. So this also takes care of that, right? We can see how there would be a second base case. I think some smart Java programmers out there are recognizing, well, I made another base case, but wasn't that unnecessary? Couldn't I have just said if n was less than 2, return 1, and then that resolves when n is 0, that resolves when n is 1. I think it gives an incorrect answer for negatives, but we don't have to worry about that. You're right. You could combine those two base cases together. The reason I'm showing it this way is I want you to see that you can have multiple base cases. All right, I think that's what I'm going to do right now for this video, and I'll show you more examples of recursive methods in the next video. Thanks for watching.